So the picture looks something like this. We've got this mass at the origin, let's say M1. We've got M2 out here at x equals to 14, right? This is at x equals to 0. What else do we know? Oh, one's at 2 meters, right? Oh. So the center of mass is here. Okay. Oh, and we're told that M2 is equal to, what was it? We don't know the mass of, we don't know M1? Do we know the mass of M1? I don't see it. Oh, part A. Duh. What else do we know?
Velocity of the center of mass.
Ah, okay, so here's the deal. If x, let's say x bar is equal to the center, this is where x bar is, okay? X bar, let's say x bar is the center of mass, right? X bar is equal to 1 over m1 plus 0.2, right? Times m1 times 0 plus m2 times 14. Or, well, more to the point, let me leave this as m2. That's the center of mass, right? It's essentially the weighted average, right? But cancel out the g. Now what is this here? Well, this is really just what, 14? This is 14m2, 14 times 0.2 divided by m1 plus 0.2. But since we know that 2 is equal to 14 times 0.2 divided by m1 plus 0.2, you can solve for what? You can solve for m1, right? Funny. So that would be my first thing, solve for m1. 2m1 plus 0.4 is equal to 14. What is 14 times 0.2? 2.8, right? So what's m1 equal to? M1 is equal to, I'm going to cheat, 1.2 kilograms. Yeah. So what's the momentum? Momentum is equal to the total mass, right? The total momentum for the system is the total mass times the velocity of the center of mass, which I could call v bar here, which you're given. So that's what? That's 1.2 plus 0.2 times, what is the, what did I say, 6? Is it 6? 6 meters per second. And that would be like 1.4 times 6, which would be, yeah, 8.4 kilograms meter, 8.4 kilogram meters per second. And then you can, how would you figure out the velocity of the one at the origin? How would you figure out part C? Well, for part C, you have that 8.4, kilogram meters per second is equal to the momentum of 1 plus the momentum of 2, right? But the momentum of 1 is what? m1v1, and the momentum of 2 is m2v2. You know everything here except for what? well, excuse me, what is V2? That's given at the start of it, at rest. See? So this is 0, and so you can easily solve this for V1, right? That would give you part C. But the big idea here is the relation between the center of mass, right? The velocity of the center of mass, the momentum of the whole system, and how that is given to you by superposition of the momentum of the constituents of the system, adding them together. This problem is more fun when it's more two-dimensional. This problem is very one-dimensional. You can easily change this problem so that you're given directions and it becomes a problem of vectors. It's more interesting that way. This is a good starting point, though.
So like number 5?
Like number 5, yeah, probably. And the same homework?
Yeah.
Yeah. Yeah, pretty much. But I don't know, but I don't think that number 5 is a good problem, right? But it doesn't invite you to think about the center of mass concept two-dimensionally. I'm just, as a qualification on my comment, and I'm not, you're right, I mean, that's a two-dimensional problem, but there exist like 2 or 3-dimensional problems which also explore the center of mass concept. Maybe I didn't find one. I should really cover that. I mean, we covered it in the derivation. Oh, anyway, I shall shut up. Have a good break, you guys. Well, my break hasn't started yet. There's still this insidious